Alright, in this video we're going to take a look at why we even bother to do this factoring stuff in the first place. So to illustrate this, I'd like you just to take a look at this equation I have and think about using your regular algebra techniques to try to solve for x. Okay, what would you do first? Well, you might look at this and say, let me see, I'll move this 3. Wait a second, if I do that I have to take the x with it. And if I try to move the 3x over here, I can't put it with the 28, so hold on, that's not going to work. Maybe I'll move the x squared over here. Well, dang it, that doesn't go with the 28 either. Oh, maybe I'll put the x squared and the 3x together, but hold on, they're not like terms, so I can't add them together. And what you start to see is you don't have a strategy using your regular algebra techniques that you've learned up till now to solve this. No matter how hard you try to rearrange it, the x squared and the 3x just don't go together with addition or subtraction. So what we're going to use to solve this is a little thing called the zero product property. And all that really means is something very simple. Okay? I'm going to have A times B. And what I want you to do is think for a second, if A was 0, does it really matter what number B is? 0 times anything is still 0. And what if I were to make B equal 0? Does it really matter? Well, let's just say A was 10. Does that really matter how big A is? If B is equal to 0, then is this still a true statement? The answer is yes. We're going to use that little property to get us a strategy here to solve this thing. So here's how we're going to approach it. We're going to start by setting this thing up and making the whole thing equal 0, which means I need to get all of it onto one side of the equal sign. So I'm going to subtract 28 from both sides. You might say to yourself, well, I can't put that with a 3x. It doesn't go together. You're absolutely right. Let's just write what we have. X squared plus 3x minus 28 equals 0. There's nothing left on the right side. Now, what you should recognize is that this trinomial on the left, the 3 terms, can be factored into 2 quantities. And keep in mind, when these 2 quantities are written this way, we're saying they are multiplied together. So it's like this, A times B. I just have 2 quantities I don't know. And they're equal to 0. That's what I have right down here on the left. So what we're going to do is run through and factor this. And if we go back to our backwards FOIL technique, x times x is x squared. Negative 28 comes from 7 and 4, but one of those needs to be negative, so I'm going to make the 4 negative and the 7 positive. Now, that's factored. The reason we factored it is now I basically have this situation right here. I have 2 numbers multiplied by each other that equal 0. The only difference is I don't know these numbers. They're both unknown. So what I need to know is what makes those 2 quantities equal 0. There's actually 2 answers to this equation. So let's take this one right here. This quantity is x minus 4. I don't know what that number is, but in order for it to equal 0, x would have to be positive 4. Okay. Now if I put positive 4 into my original equation, I'm going to get 0 for an answer. We'll try with this one over here. X plus 7 equals 0. In order for this to work, x has to equal negative 7. There's my other solution. So the answer to this equation, my very first original equation, this thing up here, actually has 2 different answers. And you could check them both and see if they both work. X could be 4 or negative 7. Both answers work in this case. So that's why we factor. We basically don't have a choice. We're going to learn a bunch of techniques as you move on in algebra to tackle equations that your old school methods that are kind of simple just don't work anymore. So this is one technique you'll see quite a bit of. Try to factor it and then solve each piece that's unknown and make each piece equal 0.